Good evening. You're looking live at Space Launch Complex 40 at Cape Canaveral Space Force Station, where SpaceX is counting down to the launch of a Falcon 9 rocket with 22 second-generation Starlink satellites. Liftoff is scheduled for 1:17 a.m. Eastern Time. That's 5:17 UTC for our viewers around the world. This will be the third Starlink launch this week. SpaceX launched 22 satellites from this very launch pad last Sunday, and then on Monday followed up with the launch of 15 more satellites from Vandenberg Space Force Base in California. I'm Stephen Young, and I'll be providing commentary from Spaceflight Now's News Bureau at the Kennedy Space Center press site. I'm joined by my colleague Adam Bernstein, who will be operating the cameras this morning. And the countdown clock is now at T-minus 1 hour and counting. We'd like to thank all of you for joining us for our coverage tonight. We can't do these broadcasts without the support of our viewers and, in particular, our members. We'd like to thank everyone who's made a contribution to help support our coverage. One way you can do that is by hitting the thumbs up button to like this stream. And if you haven't done so already, click the subscribe button and ask to be notified. That way you won't miss any of our future launch coverage. And if you'd like to help us more to improve and expand our coverage of the space program, please consider making a donation through YouTube's Super Chat feature or by becoming a member of our YouTube channel. You'll get access to special member-owner videos and discounts at our online shop. We're currently offering our members a 4K RAW feed from our camera pointed at the launch pad tonight. T-minus 58 minutes and counting. We're about 20 minutes away from the point in the countdown when the launch director will give a go for the start of propellant load for this morning's launch. SpaceX is running the countdown from its brand new control center at Hangar X. It's located on Kennedy Space Center property on the other side of the Banana River from the launch pad. It's also where SpaceX refurbishes and prepares the Falcon 9 first stage boosters for flight. The launch director will conduct that go-no-go poll electronically. It's not like the polls that you might have heard for other rockets, which are conducted verbally over the countdown communications nets. This one is purely electronic, and the launch team votes go or no go using a computer mouse. By this point, the chief engineer should have already conducted a technical poll. There was some stormy weather that moved through the Space Coast area this afternoon, but that has all moved offshore and dissipated. The last forecast we received on Wednesday from the 45th Weather Squadron gave a 90% chance of acceptable conditions for launch at the end of tonight's launch window. We're also not expecting the weather in the recovery area to be a problem for tonight's launch. And there's been no sign of any issues with the upper level winds, which sometimes can cause a delay. So everything looking good as far as the weather. SpaceX was a little late getting the rocket out to the launch pad and upright in position for launch. It didn't start that work until about 7:30 p.m. tonight. Usually the rocket is lifted upright about 6 hours before launch, and often many hours more than that. We should now be receiving audio from SpaceX's launch control. So we'll be listening in for any word from the launch director on whether they are starting their poll. Sometimes we don't hear anything until that poll is complete, and other times we hear the launch director call out that the poll is open and the launch team can register their go, no go vote.
Attention operators on countdown. The propellant load and launch go no-go polls open in 57.70 of 1.160.
And there we have it, the launch director confirming that the poll is now open. And the launch team will now be giving their go or no-go for tonight's launch. Countdown clock is currently approaching T-minus 50 minutes. If they give the go for launch, the loading of propellants aboard the Falcon 9 will begin at T-minus 35 minutes. Liftoff is scheduled for 1:17 a.m. Eastern Daylight Time. That's 5:17 UTC. That's the last launch opportunity available to SpaceX tonight. So if we don't get a go for launch in the next 10 or 15 minutes or so, then we won't be seeing a launch tonight, and SpaceX will probably reschedule for Friday. But right now, there's no indication that SpaceX is working any technical problems, and the weather is looking favorable for tonight's launch. While the launch director is conducting their poll, let's take a look at the trajectory for tonight's mission. This is the Starlink 6-9 mission, a launch of 22 Starlink satellites. You're looking at an aerial view of Space Launch Complex 40, where the Falcon 9 is standing. And there you can see the trajectory to the southeast. The Falcon 9 is targeting an orbit of 43 degrees inclination, and it will be skirting the Bahamas as it heads to the southeast. The first stage, once it completes its work, will separate and make a landing on the drone ship, just read the instructions, which is stationed there in the Atlantic Ocean east of the Bahamas. The drone ship is about the size of a football field. The downrange distance is about 643 kilometers from the launch site, the point at which the booster will land, making its 9th flight tonight. And the payload fairings should be recovered just a little bit further downrange in the ocean. Those payload fairings are picked up by one of SpaceX's small recovery ships. Although you can't really see it in our camera views of the launch pad, the skies overhead are a little overcast. The clouds are moving fast. There's been no thunderstorm activity in the area, which is the main watch item for the 45th Weather Squadron, which provides the go, no go weather forecast. And SpaceX has confirmed that the weather is 90% go. So weather conditions are looking good for tonight's liftoff. Let's take a closer look at the Falcon 9 vehicle. It stands 70 meters or 229 feet tall and has a diameter of 3.6 meters or 12 feet. The bottom 2/3 of the rocket is the first stage. Today's first stage booster has flown 8 times before. It is designated tail number 1069 in the SpaceX fleet. At the base of the first stage are the 9 Merlin 1D engines, which burn rocket-grade kerosene and liquid oxygen to produce 1.7 million pounds of thrust at liftoff. Around the engine compartments are the black carbon fiber landing legs that will be used to land the first stage on the drone ship in the Atlantic. Above the first stage is the interstage. This is a composite structure consisting of an aluminum honeycomb core surrounded by carbon fiber. You can see the deployable hypersonic grid fins that will be used to provide stability and steering for the Falcon 9 as it falls through the atmosphere on its way down towards the drone ship. These are titanium winglets. They're made of titanium because of the metal's strength, and they're needed because of that strength is needed because of the heating as the rocket falls tail first like a dart back towards the Earth. At the top of the interstage are 3 mechanical latches that attach the interstage to the second stage. After the main engine cutoff, high pressure helium is used to open those latches, and pneumatic pushes ensure there is a clean separation between the interstage and the second stage. The second stage engine nozzle is housed inside that interstage adapter until stage separation. The upper stage is powered by the single Merlin engine called a Merlin vacuum engine, or MVAC engine. As you can see from the image here, it's equipped with a large nozzle, and that is optimized for burns in the vacuum of space. The MVAC engine produces more than 200,000 pounds of thrust. It's going to be fired twice on today's flight to place the 22 Starlink satellites into their intended orbit. The MVAC engine burns the same propellant mix of kerosene and liquid oxygen as the first stage. It will ignite.
Falcon 9 tanks are venting for the start of prop load.
And we just heard the call from the launch team that the tanks are being vented, which is a sign that the go has been given for propellant load. So we'll be going ahead.
On countdown, polling is complete, and the team has polled go for propellant load and launch. Stand by for abort instructions. For non-urgent, no-go conditions, brief the CE or LD, and they will approve aborting the countdown. For urgent issues affecting the safety of the operation, operators shall call hold on the countdown net. Launch control will abort the launch auto sequence and immediately proceed into launch abort. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count.
Let's quickly resume our tour of the Falcon 9. At the very top of the rocket is the payload fairing containing the 22 Starlink satellites. That fairing is made of a carbon composite material. It's 13 meters tall, which is about 43 feet, and 5.2 meters or 17 feet in diameter. The two halves of the payload fairing will be recovered downrange. They will gently splash down on parachutes, and the recovery ship will fish them out of the water and return them to the Cape for refurbishment and reuse. We're now standing by for the start of propellant load.
Launch auto sequence has started.
And that call that the launch auto sequence has started means that the automatic sequence to load propellants aboard the Falcon 9 is now underway at Space Launch Complex 40. Liftoff is set for 1:17 a.m. Eastern Time. The ground computers are now managing that automatic sequence to pump the propellant aboard the Falcon 9. At this stage in the countdown, 3 of the 4 propellant tanks on the rocket will be loaded. First, there are the kerosene tanks on the first and second stage. And then there's also the liquid oxygen tank on the first stage. The Falcon 9 uses a highly refined rocket-grained kerosene known as Rocket Propellant 1, or RP1 for short. The oxidizer used by the Falcon 9's Merlin engines is a super-chilled liquid oxygen. By densifying the oxygen, SpaceX can pack in more propellants and gain more performance than is possible with the standard liquid oxygen used by most rockets. And we're now taking a close-up view of the Falcon 9, and you can just make out the very first signs of propellant being loaded aboard the vehicle. If you look towards the base of the rocket, just above the bluish colored diagonal structure you can see towards the bottom, that's the hydraulic system that operates the strongback. Just above that, on the left side of the vehicle, growing larger with every second, are vapors forming on the outside of the rocket. This is caused by the hot and humid Florida air coming into contact with the structure of the rocket, which is now slowly filling with those super chilled propellants, and the water vapor in the air is condensing out and forming that little cloud of fog that is starting to grow and expand and will eventually envelop the whole of that first stage liquid oxygen tank. It's also a good way of gauging how much propellant has been loaded aboard the rocket. You will see that band of vapor and frost gradually work its way up the vehicle as the liquid oxygen is pumped aboard. Just a reminder, if you haven't done so already, please hit the like button, the thumbs up. That really helps us out, spreads the word about our coverage, gets more people tuning in and watching these exciting liftoffs from Cape Canaveral. Now less than 30 minutes to the launch of the Falcon 9. At this point in the countdown, the loading of helium aboard the Falcon 9 will be starting soon. That helium is loaded into pressure vessels inside the propellant tanks. It is used during flight to pressurize those tanks and force the propellants down towards the engines. It's a crucial part of keeping the engines fed with their liquid oxygen and kerosene. With propellant loading underway, let's take a look at the major milestones ahead in the countdown. We've already reached the go for propellant load and the start of RP1 kerosene loading on the first and second stages, and the loading of liquid oxygen aboard the first stage of the Falcon 9. Next up will be the loading of liquid oxygen aboard the second stage of the Falcon 9. Before that, at about T-minus 20 minutes, we will hear the confirmation that loading of kerosene aboard the second stage is completed. And at that time, we'll see the so-called big vent. That's a large vent that comes from the strongback structure that sits alongside the Falcon 9. That vent is part of the process to chill down the plumbing that runs up that structure to provide the propellant to the second stage. So at the completion of that big vent, we'll see the start of liquid oxygen loading aboard the second stage. The next major milestone comes at T-minus 7 minutes and counting. At this point, the Falcon 9 begins the first stage Merlin engine chill. This is a process that involves opening valves and allowing a small amount of the cryogenic propellant to enter the engines and flow through the turbo pumps. This process cools down the engines and the plumbing to prevent any thermal shock when the engine ignition sequence starts at about T-minus 3 seconds. Four and a half minutes before liftoff, the retraction of the strongback will get underway. The strongback is the lattice structure that sits alongside the rocket and provides umbilical connections with the second stage and the payload. That strung back will retract to an angle of about 1.5 degrees. It leans back ever so slightly. You'll be able to see it in this angle from our camera. It will stay at that slight tilt until right before liftoff, and as the Falcon 9 lifts off the pad, it will pull back in a more rapid fashion so that the Falcon 9 can climb away. At about T-minus 1 minute, the onboard computers will begin the final pre-launch checks and take control of the final 60 seconds of the countdown. The propellant tanks will be brought up to flight pressure. The SpaceX launch director will give their final go for liftoff. And then the engine ignition command will be issued at T-minus 3 seconds. In those final seconds before liftoff, the onboard computers will verify that the engines are running as expected, that all the pressures and temperatures are correct, and the valve positions are in the right place. And if all is well, then when the clock reads 0, the Falcon 9 will lift off on this mission to deliver 22 Starlink satellites to orbit. As you can see, that frost is really building up now, and you can see how as the tank fills up, it creeps its way up the first stage structure. We're now at T-minus 22 minutes and 25 seconds and counting. If you're just joining us, you're looking at live video of a Falcon 9 being fueled for launch at Space Launch Complex 40 at Cape Canaveral Space Force Station. Liftoff is scheduled for 1:17 a.m. Eastern Time. The Falcon 9 is carrying 22 second-generation Starlink satellites. The Falcon 9 will head southeast from Cape Canaveral. It's targeting an orbit 43 degrees inclined to the equator.
Stage 1, Pogo.
We're coming up on the start of the big vent. Watch out for that. There you see the big cloud of billowing vapor. That super cold gas hits the humid Florida air.
Stage 2, RP1 load is complete.
Confirmation from the launch team that the loading of Kerosene aboard the second stage is now complete. This vent is part of the process to chill down the propellant lines that run up the strongback structure and are used for the loading of cryogenic, superchilled, densified liquid oxygen. At this stage in the countdown, the first stage is being loaded with its kerosene load and liquid oxygen. We're about 3 minutes away from the start of loading of liquid oxygen aboard the second stage of the rocket. We're nearing the conclusion of the big vent. Stand by for the start of liquid oxygen load on the second stage.
Stage 2 LOX load has started.
There's the confirmation that the loading of liquid oxygen aboard the second stage is now underway. T-minus 15 minutes. Let's take a look at the flight history of this Falcon 9 booster. It's tail number 1069 in SpaceX's fleet. The first flight for this booster was in December 2021. It was a mission for NASA delivering cargo to the International Space Station, but it was a bit of a rocky start for this Falcon 9 first stage. The booster appeared to successfully land on the drone ship, just read the instructions, but when it returned to port, it was clearly listing to one side, and it had crumpled engine bells that were clearly visible to observers at the port. With that amount of damage, it took 250 days before it flew again, and there was some significant repair and refurbishment work required. Its next flight was in August 2022, and on that flight it carried 54 Starlink satellites into orbit. It then took on a couple of commercial missions, including the launching of the Hotbird 13F satellite for Eutelsat. In December of 2022, it launched a batch of satellites for OneWeb, a competitor to SpaceX's Starlink network. OneWeb had originally launched most of its satellites on Soyuz rockets, and when Russia invaded Ukraine, it had to find an alternative launch provider, and one of those alternatives was SpaceX, and they agreed to launch the OneWeb satellites, even though OneWeb was a competitor of Starlink. So the next mission was again a Starlink flight carrying 53 of the version 1.5 satellites. That was followed in March of this year with the SES 18 and 19 satellites, communication satellites for SES. It was back on Starlink duty, launching 56 satellites back in May and another 56 in June. And on today's launch, it will be making its 9th flight. Let's take a look at those Starlink satellites that are packaged up in the fairing of the Falcon 9. This mission is designated Starlink 6-9. It will be the 11th launch of SpaceX's next generation of Starlink satellites. It's actually the 3rd launch of Starlink satellites this week. These satellites are known as the Starlink V2 Mini or version 2 Mini design. This is an intermediate design that SpaceX has developed for the Starlink network in between the older generation called the version 1.5 and the next generation full-size version 2, which SpaceX intends to launch on its fully reusable Starship vehicle. This file photo shows what the satellites look like flat-packed in their launch configuration. It was taken before the first second-generation Starlink launch back in February of this year. and shows how the satellites look before they're enclosed in the payload fairing. SpaceX has made its Starlink service available on all 7 continents, including Antarctica. In early May, SpaceX said it had more than 1.5 million subscribers to the Starlink network. T-minus 7 minutes.
Engine chill is starting.
There we have confirmation of the start of engine chill. That's the process that is used to precondition those Merlin engines prior to the start of the engine ignition sequence to avoid them suffering any kind of thermal shock.
Stage 1 RP1 load is complete.
There's confirmation from SpaceX that the loading of kerosene aboard the first stage of the Falcon 9 has been completed. So at this point, liquid oxygen is still being loaded on both the first and second stage of the Falcon 9. T-minus 5 minutes and counting. The next major step in the countdown will be the retraction of the strongback.
Falcon tanks are pressurizing for strongback retract.
The strongback retract will begin with the opening of the clamp arms, which we can now see in this view from SpaceX. The video from SpaceX does come with a little bit of a delay. You'll notice there's a difference between our countdown clock and the SpaceX countdown clock. Those arms are now open, and the strung back is moving away from the vehicle, as you can see in this view from our camera at the Kennedy Space Center press site. The strung back retracts to an angle of about 1.5 degrees.
Stage 1 LOX load is complete.
The loading of liquid oxygen is now
Stage
complete.
1 POGO.
The rocket's autonomous destruct system has been armed, and liquid oxygen topping will be terminated soon. T-minus 2 minutes.
Stage 2 LOX load is complete.
And there we have it. The Falcon 9 is fully loaded. 1 million pounds of propellants are on board in readiness for the liftoff at 1:17 a.m. this morning. We're seeing some venting at the launch pad as SpaceX purges the propellant lines prior to launch.
Gas launch closeouts has started.
T-minus 1 minute, the onboard computers will take control of the countdown.
Falcon 9 is in startup.
And there's confirmation the onboard computers have control. We're listening for the launch director's final go.
Starlink 6-9, go for launch.
And there we have it, the go for launch. "20 seconds. 15. 10. 9. 8. 7. 6. 5, 4, 3, 2. We have ignition and liftoff. Liftoff of the Falcon 9. The Falcon 9 has cleared the tower. It's now heading downrange. Let's listen in to the roar of the Merlin engines. Stage 1 propulsion is reported as being nominal.
Power and telemetry.
1 minute into flight, the engines are being throttled down ahead of the point of maximum dynamic pressure. Falcon 9 traveling faster than the speed of sound.
Max Q.
Less than a minute left in the burn of the first stage. Those Merlin engines are producing 1.7 million pounds of pressure. Falcon 9 is already at an altitude of over 30 kilometers. As it heads downrange at a speed of more than 4,200 kilometers per hour. The upper stage engine is being chilled down. Approaching main engine cutoff, or MECO. The Merlin engines will shut down. That will be followed by separation and ignition of the second stage. It looks like we've had MECO.
Main engine cutoff.
Stage separation confirmed.
And there we see in this view from SpaceX the separation of the first and second stage and the ignition of the MVAC engine, the Merlin engine on the upper stage. On the right-hand side of the screen, you can see the upper stage Merlin engine, and on the left-hand side, the first stage, which is extending its titanium grid fins.
Fairing separation confirmed.
And there's separation of the payload fairing, our first view of the Starlink satellites. The first stage continues to climb. It's currently at an altitude of 105 kilometers. As you can see from this ground track, it will arc upwards until it reaches its maximum altitude, and then it will start falling back towards the drone ship. Just read the instructions in the Atlantic. SpaceX is still getting a tracking camera view of the second stage. That's the image you can see on the left-hand side of the screen. The upper stage is now traveling at more than 10,000 kilometers per hour and is at an altitude of 140 kilometers, while the first stage is building in speed 7,140 kilometers per hour, an altitude of 116, now 115. It has peaked. It is now starting its descent, and you'll see that speed pick up as it plunges back into the atmosphere. That Merlin vacuum engine, it's nozzle designed to produce optimum thrust in the vacuum of space, glowing as it heats up from the exhaust from the burning of the liquid oxygen and kerosene.
Acquisition of signal, Bermuda.
The first stage is now at 7,500 kilometers per hour. We're coming up on the entry burn. That burn is crucial to slow down the first stage. 3 of its engines will be ignited in that burn. Without that burn, the first stage would burn up in the atmosphere from the atmospheric friction. It's now approaching 8,000 kilometers. Watch for when that burn starts and the speed should dramatically decline as
Stage
the
1,
brakes are
FTSO safe.
slammed on.
Stage 1 entry burn startup.
And there we can see it. The first stage entry burn is underway. You can see that speed dramatically falling, slowing the Falcon 9 first stage's descent through the atmosphere.
Stage 1 entry burn shut down.
Now under 45
Stage 2,
kilometers in
FTSO
altitude as it heads towards the drone ship. Just read the instructions, which is stationed to the east of the Bahamas, about 640 kilometers downrange from the Cape. The Falcon 9 first stage will make another burn
Nominal trajectory.
just prior to landing. And that's the burn that slows it down and steers it to a hopefully pinpoint landing on that drone ship. SpaceX has 3 of these converted ocean-going barges that it uses for the recovery of Falcon 9 boosters.
Stage 1 transonic.
The first stage now traveling less than the speed of sound at an altitude of just about 6 kilometers. We've not had any video from the first stage for a few minutes, but hopefully we'll get that back in time for the landing. Second stage continuing on its way to orbit. Accelerating to 22,000 kilometers per hour, at an altitude of
Stage
155. There's the landing burn underway on the first stage. On the left-hand side of the screen, the drone ship coming into view.
Landing leg deploy. Stage 1 landing confirmed.
And there we have it. The first stage has landed on the drone ship.
Loss of signal, Cape.
We're now waiting for the cutoff of the second stage. That first stage booster, booster 1069, making its 9th flight. We had verbal confirmation of the shutdown. The video broke up a little bit there. We didn't quite see the engine shutting down, but we did have the verbal confirmation.
Nominal orbit insertion.
And also confirmation from the launch team that the second stage has placed the Starlink satellites into their nominal parking orbit. There is one further burn required from the second stage to refine the orbit. It's only a 1-second burn. It's just a little nudge just to put those satellites into the precise orbit that is required for this mission. Let's take a look at that target orbit. So the Falcon 9 second stage is aiming for a target orbit of 183 miles or 294 kilometers by 176 miles or 284 kilometers. The inclination is 43 degrees to the equator. So with the Falcon 9 now in a coast phase, we're going to end our coverage on our dedicated stream here, but we will continue to provide this tracking map and some updates during the deployment of the Starlink satellites. Those Starlink satellites are due to be deployed about an hour and 5 minutes after launch. The burn of the second stage, just a short 1 second burn, is due to occur 53 minutes and 59 seconds into the flight. There'll be one more burn of the second stage after the deployment, and that's to deorbit the second stage. That's part of the efforts to reduce orbital debris. That burn will drive the second stage into the atmosphere, and it will burn up harmlessly over the ocean. So we won't get any video of the separation of those Starlink satellites, but we did get a view after the first launch back in February that was tweeted by Elon Musk, and we could take a look at a replay of that file footage. This shows the retention arm that holds the satellite in place during launch swinging away, and the flat-packed satellites drifting off into space. They are not attached now, and they will gradually separate over time. It's quite an interesting maneuver, particularly from this perspective with the camera mounted on that retention arm. The previous satellite design, the version 1.5 satellites, used a retention arm that was jettisoned into space. The version 2 minis, the retention arm that held them in place inside the fairing is hinged and remains attached to the second stage. And again, this is part of the effort to reduce orbital debris, because that whole mechanism is disposed of with the second stage when it burns up in the atmosphere. Once again, there'll be no more video from SpaceX as they've ended their webcast, but we should hear audio confirmation of the deployment, and we'll bring that to you in our Launchpad Live stream. So thank you very much for joining us. We'll be back for the next launch from Cape Canaveral, which will probably be in 4 or 5 days' time. Another Starlink launch from the Cape. So stay tuned to updates on our website, spaceflightnow.com, and move over to our Launchpad live stream for continuing live coverage of the deployment of the Starlink satellites coming up 1 hour and 5 minutes into flight. So on behalf of myself, Stephen Young, and Adam Bernstein, who operated the cameras tonight, we want to wish you a good night, and we'll see you next time.